Good day everyone, I am Angel Joyce Daruca and I will be the first reporter for today's presentation. I will be discussing the topic linear programming. So what is linear programming? Linear programming is a mathematical method nga ginagamit para makuha ang best possible nga solution sa isa ka problem. So kung naatay limited resources like money or materials, also time, ang linear programming makatabang na para makadecide ta og efficient sa ato ang resources para ma-maximize or ma-minimize ang cost and profit. So the word linear means the relationship that can be shown lay or straight line like some math equation such as ax plus by is equal to 0. Then the word programming is about sa pagplan or sa pag-allocate sa resources sa mas nindot nga pamaagi. In short, ang linear programming means nagaplano ta with linear relationship para makuha na to ang best nga result. Next, the requirements for linear programming to work. There must be, first, a clear objective. So, dapat na kay clear nga objective like to gain the highest profit. Second, limited resources such as time, money, or materials. Then, alternative choices. Kanang naa kay different way para magamit ang imong resources, then interrelated decision variables. So, nag-asabot ni nga all choices affect one another. And of course, constraints or limits on the resources. In assumption, linear programming also follows some assumptions. First, the proportionality. Magbago lang directly ang proportional. Then, additivity. Mao ni ang total result pag naa kay i-add. Next, the continuity. Mao ni ang value that it can be a whole or fractional. Then, certainly, all data and condition are known. Lastly, finite choice. Kanang naay limited nga option para mo pili. Then, application. Linear programming can be used in many areas such as first, industry para sa production planning. Then, military para sa resource management. Then, economic para sa pag-budget. And marketing para sa pag-advertise plans. Also, distribution para makakita og mas barato ug mas dali nga pag-deliver. So, in overall, the linear programming is very helpful tool para maka-create og much better decision and using the limited resources wisely para makuha nato ang best possible nga results. That's all for my topic about linear programming. Thank you for listening. Now, let's move on to the next reporter.
Good day, everyone. My name is Riani Felisilda, and first I will discuss the areas of application of linear programming. So we have here the industrial application. So, product makes problem. So, in linear programming, maka-help siya para maka-determine ka kung unsay best or most favorable na quantities and amount of different products na i-produce. Like labor, mga materials na kailanganon sa machine time para ma-maximize imong profit given the limited resources. Next is blending problems. So in blending problems, linear programming helps to determine the optimal or the right na amount of ingredients na imuhang isagol sa kanang pag-create ana na final products. And also ma-meet nimo ang right na quality or standard in a minimum cost. So next is production scheduling problem. So here, ang linear programming maka-help siya para maka-come up ka og plan sa inyong production schedule over a time in which ma-meet nimo ang mga demands or schedules sa kana na time, and also maka-minimize ka og cost and other expenses na bayronon given the capacity and the limitation. Next is assembly line balancing. So diri ang linear programming ma-apply siya in which maka-distribute mo og best arrangement or ma-balance ang mga given tasks sa work para ma-minimize ninyo ang oras na magamit and also para nindot sad ang flow sa inyong production. Next is make or buy problem. So, diri maka-help ang linear programming in which maka-decide ka whether to make or mag-manufacture na lang ka og some products sa internally or magpalit ba ka sa gikan sa external supplier. So, while gina-consider nimo ang cost and quality requirements. So, next is management application. Media selection problem. So, diri ang linear programming ma-apply na sa media, makadetermine mo og best advertisement budget across the different channels like TV, print, mga radio, and even online para mas daghan ang ma-reach and effective siya. Next is portfolio selection problem. So because when it comes to management biya jud no, gusto biya jud ta na walay mga problema ang kuan or ma-minimize ang risk. So in investment, importante pod na makapili ta og nindot na investment. So linear programming helps to make or to select the best investment in which maka-return siya og dagko sa unsa man ang imong gi-invest. Next is profit planning problem. So if naay kanang problema no sa pagplano sa profit, so ang linear programming helps para maka-develop mo og comprehensive plan nga nindot para ma-minimize inyong gasto o inyong revenue para ma-maximize ang overall productivity sa inyong business. Next is transportation problem. So, kini, isa po ni siya sa mga problema ang aning transportation. Sa kay kung gusto majud kaayo ang mga business owners na makatipid sila sa kaning gasto unon, so less transportation, linear programming helps para makaka-determine mo og best shipping route or kanang location ba sa inyong warehouse in which mahatod ninyo inyong product at different location while naka-minimize mo og cost sa transportation. So, next is miscellaneous application. We have diet problems. So, with the help of linear programming, in diet problem, maka-determine ka og unsay best nga combinations of food in which meet nimo ang required na nutrition sa imuhang lawas in a lower cost. So, kanang imuhang goal ba is para maka-minimize ka og cost while na-meet nimo ang required nga nutrition, calories, and all sa imuhang diet. So, kana no, linear programming helps jud ana sa diet problems. Next is agriculture problem. So, as a farmer, sa mga farmer, kay ang kaning mga farmer nagagamit po ni sila linear programming para makabalo sila unsay best na season na ang kaninga crop mo grow og nindot pilay kadaghanon sa tanan nga mga resources na gamiton og para makabalo sa sila na ang kaninga time nindot ni siya para ang kaninga crop nindot og tubo, nindot ang condition, and even sa market, sa nindot ani na kuan season. So, ana na mga factors maka-affect siya sa agricultural problems. So, linear programming helps sa mga ni ana na situation sa mga agriculture. Next is flight scheduling problem. So, sa flight scheduling problem, ang linear programming maka-help para maka-create mo og flight schedule in which ma-meet ninyo ang demand or gusto sa customers. Like, para sa example, sa mga lingkuranan, sa ilahang time schedule, and even bisan og pila ang capacity na maigo sa plane. So, maka-carry ang plane o pila ka buok ang mag-carry sa plane. So, linear programming helps pod sa flight scheduling problem. Next is facility location problem. So, diri kanang maka-help ang linear programming para makakita mo og nindot nga location or site for the new facilities like sa mga warehouse, sa mga factories in which dili mo madak-an sa transportation, and ang inyong location is daghan og customers, dali ra kaayo makita sa mga customers, ma-meet ninyo ang mga needs sa customers kay nindot ang inyong site, and also maka-minimize ka og cost kay dili na nimo need mag-transportation pa or uban pa na mga expenses tungod kay nindot na nakakita nakadetermine mo og nindot na location for that facility. So next is advantage of linear programming. We have it helps in attaining optimum use of productive factors. So linear programming helps to determine or allows na makamake mo og best or most efficient use of resources like sa labor, sa mga materials na kailanganon, and even machineries. So para dili masayang ang inyong mga resources or even dili mo makagasog dagko, so linear programming helps para kuan mo plan nga nindot sa inyong pag-produce of products. Next is it improves the quality of decisions. So linear programming jud no maka-help jud ni siya para make mo og kanang structured na decision na tabang sa inyong manage sa inyong business. And it's also maka-help siya para maka-create mo og formative na mga solution sa inyong problema. Next, it provides better tools for meeting the changing condition. So in the world of business no, naga-change man jud ang business environment. So ang linear programming naga-help siya na ang company maging flexible siya anytime, any condition. Bisa na may mga new challenges, new opportunities, so makaya niya tungod kay ang linear programming naga-help siya na ang kaninga business maka-flexible siya and easily to adapt different condition or environment. Next is it highlights the bottleneck in the production process. So sa linear programming no, gina-analyze sa linear programming ang mga constraint in which naka-identify mo which areas limited ra ang mga resources, unsay capacity sa ilahang production, and even with the help of the models on the information na gina-provide sa linear programming, magamit nimo siya para ma-improve maging efficient ang inyong production. So, kung naay advantage ang linear programming, nasa siya limitations. So, first is for large problems, the computational difficulties are enormous. So, kung magkadako ang problema, magkadako sud ang size of complexity sa linear programming na mo solve ana na problema. Kaya nagka-increase man ang mga computation in which lisod siya isolve. So, this time, medyo need nila og big effort to solve that problem para makahatag sila best solution in that time. So, it may yield fractional values answers to decision variables. So, sometimes, ang kaning linear programming, no, naghatag ni siya og mga fractional values sa decision problems. Hatag siya product solutions in which naa siya fractional values sa decision variables like mga number of units na i-produce. So, in other cases, kining fractional values kay pwede siya dili tinuod or kanang kuan siya ba practical na need siya o further na kanang adjustment para makaget mo og better or final answers. So next is it is applicable to only static situations. So ang linear programming models kay naman guni siya mga gina-base good which ang unsay ma-provide niya in that particular time. So pwede siya dili suitable in that situation nga naay magbago-bago or naga-change. So, suitable lang jud siya sa mga problem na kanang unsay ma-provide nila in that particular time or mga static situations. So, linear programming deals with the problem with single objectives. So, ang linear programming models can solve single objective functions like unsaon para ma-maximize ang profit or ma-minimize ang cost. So in business man jud no daghang decision or multiple objectives sa nabuhaton. While ang linear programming models kay maglisod siya og solve. So ang linear programming nga model suitable siya for single objective only. Types of solutions to linear programming. So naay duha ka method na pwede magamit to solve the linear programming problems. The graphical method and simplex method. So, in graphical method, mo ni siya nga method ang nagagamit og mga graphs, charts, and diagrams to solve the data. So, ang mga data naga-illustrate siya sa mga relationship between the variables. So, ang kanipong graphical method, nagasolve ni siya og two decisions variable where magplot ka dito sa mga constraints sa graph in which makita ang mga feasible region. Og dito pag makita ni mga feasible region, kakam up ko ang best solution for that region. So, next is simplex method. So, kani nga method is an algorithm used in linear programming or kanang step-by-step good siya na pagka-solve sa mga mga problema diha. So, makahatag siya og best solution for the problems nga naay mga constraint o gina-convert nilang inequalities to equations using mga slack variables, mga series of tables or matrix na nag-represent og mga problem equations. So, in the further discussion sa uban nga reporter, madiscuss man nila kung unsa ning graphical method and simplex method. Forms of linear programming. First is the canonical form. So, in kaning canonical form, it is the simplest or the standard representation of mathematical objects such as equation or matrix. So, in canonical form, all constraints are expressed in less than or equal to inequalities and all variables are non-negative. So, objective function is of maximization type. So, in canonical form, it is to maximize the objective function. So, kanang possible, pangitaon nimo ang highest possible value for that function given the constraint. So, next, all decision variables are non-negative. So, all decision or katong mga variables na ginasolve nimo dapat greater than or equal to 0. Kay maumagod na siya ang common requirement of solving linear programming. Kay kung sa real life situation magod, di magod pwede na mag-produce ka og mga product nga less negative quality sa mga product. So, all decision variables are non-negative. So, next is the standard form, all variables are non-negative. The right-hand side of each constraint is non-negative. So, in standard form, ang constraint of the right-hand side of each constraint or equation is dapat greater than or equal to 0. Kay para mahibaluan nimo nga kana nga problema ana nga equation is napa say chance na ma-solve or mahatagan og solutions. So, all constraints are expressed in equations. So, dapat na ang mga constraints naka-written siya to equation as equation. And objective function may be maximization type or minimization type. So, ang objective function, pwede siya maximization type or minimization type para flexible siya to model different types of problem.
So, my name is Jaime Fiorino. I'll be discussing the important definition of LP or the linear programming. So, first is the solution. A set of variables x1, x2, xn plus m is called the solution to LP problem if satisfies its constraint. So, meaning, as solution in linear programming kay isa sa kasit sa mga variables like x1, x2, and x3 na makatuman sa mga constraint or condition sa problem. So, example, if ang condition kay x1 plus x2 is equal to 10, then ang x1 is equal to 4 and x2 is equal to 6 is the solution because nagtuman siya sa equation. So, next is feasible solution. A set of variables x1 and x2, xn plus m is called the feasible solution to LP problem if it satisfies its constraint as well as non-negativity restriction. So meaning a feasible solution kay solution nga nagtuman sa mga constraint o sa non-negativity rule. So meaning dili pwede nga negative ang mga variables. So example, if x1 plus x2 is equal to 10 and both must be greater than to 0, then x1 is equal to 4 and x2 is equal to 6 kay feasible. But if x1 is equal to negative 2 and x2 is equal to 12 is dili siya feasible kay negative value. So in short, feasible solution kay valid or allowed na solution. So next is the optimal feasible solution. So the basic feasible solution that optimize the objective function. So ang optimal feasible solution is mao ang pinakamaayo nga feasible solution, the solution that minimize or maximize the value of objective function. So example, if we want to maximize profit 3x plus 2x2, the feasible solution nga maghatag sa pinakadako nga profit mao ang optimal. So in simple words, mao ni ang best possible answer sa LP or the linear programming problem. So last is the unbounded solution. So if the value of the objective function can be increased or decreased indefinitely, the function is called an unbounded solution. So ang unbounded solution mahitabo kung ang value sa objective function pwede mo dako moubos hangtod walay limit without violating any constraints. Example ani is if both x1 and x2 can increase infinitely, ang profit 3x plus 2x2 pod mahimong walay katapusan nga mudako siya, and it's called unbounded solution. So in short, walay limit ang result. So dili siya practical or realistic nga solution. So that's all for a definition of LP or the linear programming. So next is the variables used in LP or the linear programming. So one is, or the first is the slack variable, second is the surplus variable, and the third is artificial variable. So non-negative variable subtracted from the LSH or the left hand side of the constraint to change the inequalities in two equalities added when the inequalities and the type less than, also called as negative slack. So ang mga negative variable kay mga variable nga dili pwede mahimong negative. Inequality kay ginakuha sila sa left hand side. So to have an equal equation, kung ang inequality kay ginadungag sila sa to have equality, the variable being subtracted sa left hand side is called surplus, while the variable also called negative slack kay opposite siya sa slack variable. So in short, ginapangita niya kung pila ang sobra or kulang value sa constraint. First is the slack variable. So non-negative variable added to the LSHS or the left hand side of the constraint to change the inequalities to quality added when the inequalities are of the type or the less than. So ang slack variables kay mga non-negative variable, meaning dili pwede mag-negative nga gina-add sa left hand side sa constraint to convert ang inequality to equal. So ginagamit ni sila kung ang inequality kay less than, kung ang available resource less than or equal to a certain limit. In simple terms, ang slack variable nagpakita sa unused or remaining resource part of the limit. So example, if x1 plus x2 less than to 10, we add a slack variable s1. So therefore, x1 plus x2 plus s1 is equal to 10. So next is the surplus variable. So in same LP problems, slack variables cannot provide a solution. These problems are of the types of greater than or equal. So ang surplus variable kay non-negative variable gina-subtract gikan sa left hand side sa constraint to be equal. Ginagamit siya kung ang equality kay greater than, kung ang actual value mas dako kaysa sa required minimum. So example ani, if x1 plus x2 is greater than 10, then we subtract surplus variable. So therefore, x1 plus x2 minus s1 is equal to 10. So that is the surplus variable. So the next is the artificial variables. So this variable have no physical meaning. So no physical meaning, wala siya akma gyud na kanang meaning niya. So next is the duality. So for every linear programming problem, there is related unique problem in the same data, which also describe the original problem. So meaning in linear programming, for every problem nga atong ginatawag nga primal problem, nga naa gyud kauban nga isa ka problem nga ginatawag na dual problem. So both problems use the same data, but lain lang ang forma sa pag-research sa equations. So in simple words, every LP has a unique dual problem, the same information. So next is the primal program is rewritten by transposing the rows and columns of the algebraic statement of the problem. So in the linear programming, the primal program can be changed or rewritten to form of the program. This is done by transposing the rows and columns of the algebraic statement of the problem. So it means ang mga equation o variables sa primal problem kay gibali-bali ang posisyon. So next is the variables of the dual program are known as dual variables of the shadow prices of the various resources. So dual variables are also called as the shadow prices. Dual variables represent the value of worth of each resources in the primal problem. kung madungagan ang isa ka unit, isa ka resources sa primal problem, ang shadow price is magpakita kung pila ang madungag or madugang sa profit, which is the maximization, or pila ang masave sa cost, which means is the minimize or the minimization. So the last is the optimal solution of the dual problem gives complete information about the optimal solution of the primal problem and vice versa. So the primal and dual problems are connected into interdependent, o kung unsay result sa dual problems mao pod ang mag-reflect sa primal, just express in a different way, lahi lang yang pag-express, dili siya same sa sa primal ug sa dual. Advantages. So first is, by converting a primal problem into a dual, computation becomes easier since the number of rows constraint reduces compared to the number of columns or variables. So kung ang primal problem daghan kaayog constraint ang variables, it may be difficult to solve directly. So but if i-convert siya into a dual form, mas gamay lang ang computation, because it's vice versa, less computation and faster result, so dali lang siya makuha. Next is gives additional information on how the optimal solution changes as a result changes in the coefficients. This serve as the basis for sensitivity analysis. So that means is the dual problem gives additional information about how the optimal solution changes sa coefficients. So the next advantages is the economic interpretation of the dual helps management make better future decision. So economic interpretation of the dual helps management make better future decision, kay naghatag siya og insight or understanding sa value sa resources, og impact sa constraint sa company operation. So next is or the last is the duality is used to solve LP problems in which the initial solution is feasible. So the duality is used to solve linear programming problems kung ang initial solution sa primal problems dili feasible. So meaning wala mag-satisfy sa mga constraint, ug dili valid ang iyang starting profit. So those are the advantages of the duality. So next is the sensitivity analysis, post optimality test. So first is in formulation, it is assumed that parameters such as market demand, equipment capacity, resource consumption, cost, profit, etc. do not change, but in real life this is not possible. So in sensitivity analysis is used to study what happened to the optimal solution if there are changes in the problem's parameters. So pag sa pag-formulate sa linear programming problem, gina-assume nga mga parameters sa mga market demand, equipment capacity, resource consumption, cost og profit dili mag-usab. But in real life is nagabago siya. Example is magtaas ang cost sa mga materials or mausab ang demand sa product. That's why importante ang sensitivity analysis kay nagatanaw unsa kadako ang iyahang epekto sa mga pagbago sa parameters sa optimal solution. So next is after attaining the optimal solution, one may discover that a wrong value of a cost coefficient was used, or a particular variable or constraint was omitted. So after makuha ang optimal solution sa linear programming problem, sometimes na mali ang data o value nga gigamit. Like example is mali ang cost coefficient o naay available na constraint nga nakalimtan. So that is the example part of the sensitivity analysis. So next is the changes, or the last is the changes in the parameters of the problem may be discrete or continuous. So this means that the values in the linear programming can be changed in two ways, which is the discrete or continuous changes. So discrete changes is step by step, or example niya is cost increased from 10 to 12, while continuous is gradual or smooth. Example is demand is slowly increasing over time. So ang sensitivity analysis ginahimo to evaluate kung unsa ang epekto sa mga pagbago, kung magpabilin ba ang solusyon nga optimal o kinahanglan bang usbon ang model niya. So that's all. Continue to the next reporter. That's all. Thank you.
Good day, I am Liami S. Gaudicos, and my assigned topic is all about the continuation of sensitivity analysis and the linear programming about the case of two variables only, and also the graphical method to solve LP problems. So first, let me discuss the sensitivity analysis. The study of the effect of discrete changes in the parameters on the optimal solution is called sensitivity analysis. The study of the effect of continuous changes in parameters on the optimal solution is called parametric programming. The objective of sensitivity analysis is to determine how sensitive the optimal solution is to the changes in the parameters. So, ang sensitivity analysis of parametric programming kay ginagamit para masabtan kung unsay epekto sa mga changes sa isa ka problem sa iyang best or optimal solution. Kung ang changes kay ginabuhat hinay-hinay or step by step, tawag ana is sensitivity analysis. Pero kung ang changes kay padayon or gradual, tawag ana is parametric programming. Ang main purpose man gud sa sensitivity analysis kay para mahibal-an nato kung unsa ka stable o ka sensitive ang solution kung naay mga changes sa factors like sa cost or resources. So, makatabang ni nga method para ma-sure nga effective gihapon na nga to ang decision bisan mag-usab ang actual situation sa real life. Case of two variables only. So, makita nato dinhiya na ay mga equation. A1x plus B1y less than and greater than is equals to C1 and so far. The function z in the above problem is called the objective function. If xy satisfies all the constraints, then it is called feasible solution. The set all feasible solutions is a subset of the xy plane called the feasible region. So, ang case of two variables only kay about sa pagpangita sa best solution gamit ang duha ka variable nga x ug y. So, makita nato ang equation nga z is equals to ax plus by. Mao ang atong goal. Gusto nato nga i-maximize or i-minimize. Depende kung profit ba o gasto. Pero natay mga ginatawag nga limitations or constraints nga mag-form sa possible nga area sa graph. Each constraint of the form ax plus by is equals to c represents a straight line in the xy plane, whereas each constraint of the form less than or greater than defines a half plane that includes its boundary line. The feasible region is the intersection of finitely many lines and half planes. If the feasible region can be enclosed in a sufficiently large circle, it is called bounded. Otherwise, it is called unbounded. If a feasible region is empty, contains no points, then the constraints are inconsistent, and the problem has no solution. The extreme points of a feasible region are those boundary points that are intersections of the straight line boundary segments of the region. In a linear programming problem, the following theorem tells us when we will be successful in what points to search for. So, in linear programming, each constraint makes a line or half plane in the graph. Kung daghan nga constraints mag-abot-abot na og mag-form og feasible region, mao na ang lugar nga possible ang mga tubag. Kung sarado ang region, tawag ana is bounded, and kung walay limit or open ang region, tawag ana is unbounded. So makita nato dinhi sa diagram na ay bounded feasible region which is sa left side. So kanang region has clear borders on all sides. Clear borders on all sides siya na ay limit or boundary murag closed shape siya ba sama sa polygon. So ang mga possible solutions naa sa sulod ana nga area. So dili kayo dako or gamay ang mga values. Next is the unbounded feasible region sa right side. So, kanang nga region is open on one or more sides. So, wala siya tumoy or wala klaro nga limit sa ubang kilid. Ang mga tubag pwede mahimong very big or very small. Depende sa objective functions kung naabay minimum or maximum solution. Next is the advantages and disadvantages of linear programming. So, first is advantages of linear programming. It helps in attaining optimal use of productive factors. So, makatabang ni siya para magamit ang mga resources sa pinakamaayong nga way or pamaagi. Next, it improves the quality of decision. So, maka-improve sa decision making kay makatabang sa pagpangita sa pinaka-efficient nga solution. Next is, it improves better tools for meeting changing conditions. So, makahatag og mga gamit nga pwede mag-adjust kung mag-usab ang mga situation. Next is disadvantages of linear programming. For large problem, the computation can be enormous. So, kung dako o komplikado ang problema, lisod ug dugay jud i-compute. Next, it is only applicable to static situations. So, nindot ni nga gamiton sa mga static o dili mag-change nga situation. Next is the linear programming deals with a problem having a single objective. So, makasobra ni siya og problem nga isa ra ang goal or objective. Next is the graphical method to solve LP problems. So next is the graphical method to solve LP problems. The graphical method is limited to LP problems involving two decision variables and a limited number of constraints due to the difficulty of graphing and evaluating more than two decision variables. So this method is used only when there are two decision variables. Kay lisod na kung mulapas pa siya og duha kay dapat pa siya i-graph and i-solve. Next is this restriction severely limits the use of the graphical method for real-world problems. So, because of this limit, dili na kayo magamit sa mga true situations nga daghan of variables. Next is the graphical method is simple and very easy to understand. So, kani nga graphical method is dali ra siya sabton para sa mga basic linear programming or LP concepts. So, I have here the examples of this para mas masabtan. So, the given example is a farmer raises chickens, which is the X, and the pigs, which is the Y. He has only 100 m squares of space and 80 kg of feed available. So the animal is chicken and pig. So the space for chicken is 10 and the pig for 20. Then the feed is 5 for chicken, 10 for pig. Then ang profit is 30 for chicken and 50 for pig. So dira gikuha ang step 1 which is the constraints. So ang space sa chicken and sa pig is 10 10x plus 20y is less than 100. Then ang feed is 5x plus 10y is less than 80. The non-negative x greater than 0 and y greater than 0. Next is the step 2, objective function. Maximize z is equals to 30x plus 50y. Next is the step 3, corner points, which is the 0, 0, 0.8, 10, 0, and 4, 3. So, makita nato din hiya sa graph kung asa nagikuha. So, graphing a system of linear inequalities and identifying the vertices of the resulting feasible region, which is the area that satisfies all the inequalities. So, kaninga points are found by finding where the boundary lines of the constraints intersect, such as the origin of 0, 0, the y-intercept like 0, 0, 8, the x-intercepts like 10, 0, and the interior intersections points like 4, 3. So, sa graphing, you first graph all inequalities to determine the feasible region, which is the area where all the shaded regions overlaps. Then, sa finding intersection points naman is the corner points are the points where the boundary lines of the inequalities intersect each other. Like example, ang origin sa 0, 0 is the intersection of x and y axis, while ang sa 8, 0 is the intersection of the y-axis and another boundary line. Then sa 10, 0 is the intersection of x-axis and another boundary line. Then sa 4, 3 is the intersection of two other boundary lines within the graph. So next is the step 4, evaluate profit. So if magwonder mo asa ni siya gikan, the profits were calculated using a profit formula, also called an objective function. Mo to kaganina kong gidiscuss, that were created earlier in the linear programming process. So in linear programming, x and y axis is nag-represents of the number of two different products, and the profit formula sets how much money you earn for each unit of x and y sold. By plugging the values of x and y from each coordinate pair into the formula, you can find the total profit at that specific point. Like example, the profit formula for this problem was P is equals to 30x plus 50y. So this means na dapat makabuhat ka og 30 pesos in profit for every unit of product X and 50 pesos for every unit of product Y. So diri ang makita nato kung giunsa pagkuha sa profit figure calculated from the coordinate pairs provided. So profit at 0, 0 is nag-represents making 0 units of X and 0 units of Y. So P is equals to 30 open and close parenthesis 0 plus 50 and open and close parenthesis 0 is equals to 0. While the profit at 0.08 is nag-represents making 0 units of X and 8 units of Y. So, P is equals to 30, open and close parenthesis 0, plus 50, which is the 8, is equals to 400. So, ang profit at 10-0 is nag-represents per siya making 10 units and X and 0 units of Y. So, P is equals to 30, open parenthesis, close parenthesis, 10 plus 50, close parenthesis, open parenthesis, and close parenthesis, 0 is equals to 300. So, our profit at 4-3 naman is nag-represents 4 units of X and 3 units of Y. So, P is equals to 30, which is the 4, plus 50, which is the 3, is equals to 120 plus 150 is equals to 270. So, by calculating the profit of all the corners of the feasible region, the area that meets all the problems constraints, so ma-determine na nimo diri ang optimal production plan to maximize your profit. So in this case, producing 8 units of Y and 0 units of X yields in the highest profit is 400. So ang best solution ani is the total maximum profit of 400. That's all.
I am Erica May Habla, and my report is constructing the linear programming problem for maximization of the objective function. So, this report explains the basic steps in constructing a linear programming problem. especially when the goal is to maximize an objective such as profit, productivity, or even efficiency. So, linear programming is a mathematical method used to find the best possible outcome in a situation where there are limited resources or certain restrictions. So, to create an LP problem, there are four main steps to follow. So first, we have define the decision variables. So this means that identifying what decisions need to be made in the problem is, for example, these are the things we can control, such as how many product to make, how much material to use, or how many workers to assign. Second one is define the objective function. So this means that the objective function shows the main goal we want to achieve. For instance, it could be maximize profit, revenue, or productivity, and also to minimize cost, time, or waste. So this step sets the direction of what we want to improve or to reduce. The third one is determine the constraints. So constraints are the limits or conditions that affect our decisions. This can include available budget, materials, time, manpower, or space. Like, constraints help make the problem realistic because every business or operations has limitations. The fourth one is declare design restrictions. So, these steps means identifies whether the decision variables can only take non-negative values like the numbers of products, which can be negative, or if they can be both positive and negative. Like in the most cases, variables like quantity or cost cannot be negative. Then let's proceed the objective functions. So the objective functions in linear programming can deal with two types of goals. So we have maximization and minimization. So maximization means like increasing something beneficial such as profit, revenue, or productivity, while the minimization is reducing something undesirable like as cost, time, or waste. So this means that constructing a linear programming problem involves defining what decisions need to be made, setting a clear goal, like identifying the limitations and understanding the values the decision variable can take. Like, kaning nga process, makahelp ni siya sa organization to make it smart and efficient decisions para ma-achieve ang goals while staying within their available resources. So let's proceed to the LP model formulation and maximization example. So this example shows how to use linear programming to help a business make the best production decision to earn the highest profit while considering limited resources. So in this example, we look at the Beaver Creek Pottery Company, which makes bowls and mugs. So the company wants to find out how many bowls and mugs it should produce to maximize its profit. So given na it has only a certain amount of labor hour and clay materials available. So we have these resource requirements and the profit for each product each product provided. So this means that each bowl takes 1 hour of labor and 4 pounds of clay and earns 40 profit. And the next one is each mug takes 2 hours of labor and 3 pounds of clay and earns 50 profit. So the goal, so unsa gani ang goal? So the goal is to maximize profit while staying within the available labor and clay limits. For example, if the company has 40 hours of labor available and 120 pounds of clay available, then the company must decide how many bowls and mugs to make so that it doesn't use more than 40 labor hours and it doesn't use more than 120 pounds of clay. So it earns the highest total profit possible. So in LP form, this will be written in equation or inequalities that represent the steps of linear programming. So this example teaches us or give us the idea that linear programming helps a company plan wisely by using math. The company can find the best mix of products to make without or while wala nagasayang og time og materials, and then still makuha gihapon nila ang maximum possible profit nga ang ilahang gusto ma-achieve. So we have here to know how many bowls and mugs to make in a day to earn the highest profit while considering the limits on labor hours and clay. So we have first the resource availability. So the company only has 40 hours of labor per day and 120 pounds of clay available per day. So these are the maximum resources that can be used to produce the bowls and mugs. The second one is the decisions variable. So to make the problem easy to solve with linear programming, we represent the unknowns with symbols. So x1 equals the number of bowls produced per day. The x2 is the number of mugs produced per day. So these are the decisions the company needs to make kung pila ang each item na ma-produce. So the third one is the objective function. So the goal or the objective is to maximize profit, right? So each bowl earns 40. So we know in the previous slide that each bowl earns 40 profit and each mug earns 50 profit. So the objective functions becomes the maximize, which is the z is equals to 40 x1 plus 50 x2. So where z represents the total daily profit. So this means na ang company kay gusto nila mahibalaan ang values sa x1 and sa x2, which is the number of bowls and the mugs that make z as large as possible. So the fourth one is the resource constraint. So since there are limited labor hours and clay, we have here we have these limits as mathematical inequalities. So labor constraints, so manage ang labor constraints. So each bowl uses 1 hour and each mug uses 2 hours. So the total time cannot exceed to 40 hours. So and the clay constraints is each bowl uses 4 pounds of clay, each mug uses 3 pounds, the total clay cannot exceed 120 pounds. So these inequalities make sure nga ang company kay dili sila mulapas beyond its available resources. So the next one is the non-negativity constraint. So the company cannot produce a negative number of bowls or mugs. So x1 is greater than 0 and x2 is greater than 0. So this simply means that the production can only be 0 or a positive number. So this complete the linear programming model for the Beaver Creek Pottery. So in a linear programming, a feasible solution means a possible or acceptable answer that follows all the rules or limits of the problems. So, it's a solution that not break any of the constraints such as ang labor hours or material limits. So, the every Greek pottery, suppose the company produces X1 equals to 5 bowls and X2 is equals to 10 mugs. So here we need to check if this production plan works without breaking any resource limits. So the total profit is calculated using the formula, which is the Z is equals to 40x1 plus 50x2. So let's find the profit. So the total profit is calculated using the formula, which is the Z is equals to 40x1 plus 50x2. Substitute the numbers. So Z is equals to 40 times the x1, which is the 5 bowls, plus 50 times the x2, which is the 10 mugs. So let's calculate. So 40 times 5 is equals to 200. 50 times 10 is equals to 500. So 200 plus 500 is equals to 700. So the total profit here is 700. So let's check if the solution follows the both limits, labor and clay. So labor constraints is each bowl takes 1 hour and each mug takes 2 hours. So we only have 40 hours available. So the calculation on this is the 1 times 5 plus 2 times 10 is equals to 1 times 5 is 5 and 2 times 10 is 20. So 5 plus 20 is equals to 25 hours. So since 25 is greater than 40, the labor limits is not exceeded. So what this means? So this means that it's okay based on the available labor. So let's check the clay constraint. So each bowl uses 40 pounds of clay and each mug uses 3 pounds. So we only have 120 pounds of clay available. So if we calculate this, we have the 4 pounds times 5 plus 3 pounds times 10. So let's calculate 4 times 5 is equals to 20 plus 3 times 10 equals to 30. So it equals to 20 plus 30 is 70 pounds. So since 70 is greater than 120, the clay limit is also not exceeded. So since both constraints, labor and clay, are followed and the profit is 700, this means that producing 5 bowls and 10 mugs is a feasible solution. It's like it may not yet be the best or maximum profit solution, but it is valid because it respects all the given limits. So here comes the last of the solution. So linear programming, or like an infeasible solution, means a solution that breaks at least one of the rules or limits, like also called constraints of the problem. So this means na ang plan cannot be done in real life because it uses more on resources siya than available. So in this situation, let's say the company plans to make X1. So muna na siyang given. X1 is equals to 10 bowls and X2 is equals to 20 mugs. So the total profit would be Z is equals to 40x1 plus 50x2. So let's compute or let's calculate. So Z is equals to 40 and x1 which is times x1 which is the 10 plus 50 which times x2 which is the 20. So 40 times 10 is equals to 400 plus 50 times 20 is equals to 1,000. So 40 plus 1,000 is equals to 1,400. So the profit would be 1,400 if this plan were possible. So we test if these plans follow the labor limit. So ang labor constraints kay ang each bowl needs of 1 hour and each mag needs of 2 hours. So 2 hours, but there are only 40 hours available. So let's compute. So 1 times 10 plus 2 times 20. So 1 times 10 is equals to 10. 2 times 20 is equals to 40. So 10 plus 40 is equals to 50 hours. So 50 is greater than 40. So which means that the plan needs an extra 10 hours that we don't have. So because this goes, so nagbiyand na siya sa limit. So it violates the labor constraints. So this plans is infeasible because it requires more labor than allowed, as what I've said. So even though it gives a higher profit, which is the 1,400, it's not possible under the given limits. So ang solution kay mao ni siya, it's like a plan nga dili mag-work because naga-use siya of more resources than what's available. So in this example kay making 10 bowls and 20 mugs is not possible jud because the workers only have 40 hours of work, but this plan needs 50 hours. So if ever mag-add pa sila of 10 hours para maging effective and maging sakto sila sa limit of their work.
Good day everyone, I'm the next reporter, so I'm Eljan Laplana. So my topic is all about graphical solution of maximization model and labor constraint area and a clay constraint area na both constraint and extreme corner point solutions. First slide is the graphical solution of maximization model. So the objectives here is to maximize Z is equal to $40 x1 plus $50 x2. Here x1 represents the bowls and the x2 represents the mugs. So for the constraints diri is 1x1 plus 2x2 less than 40, and the next is the 4x1 plus 3x2 less than 120, and the last is x1 and x2 and greater than equal to 0. The next slide is the labor constraint area. It shows the graphical representation of the first constraint, which is the x1 plus 2x2 less than 40. So the shaded area on the graph kanang makita nato sa image kanang blue diha nga color mao nang shaded area, along with the 2 points labeled A and B represents mao ni siyang represents of the region of all possible combinations of bowls and mugs that satisfy this specific labor constraints. The next slide is the clay constraint area, shows the graph of the constraint 4x1 plus 3x2 less than 120. So the shaded area represents all possible combinations of bowls and mugs that satisfy this single constraint. So the next slide is the both constraints, shows the graphs of both constraints, and the area common both constraints is the feasible region. This region contains all possible solutions that satisfy both constraints simultaneously the optimal solution to the problem would be found at one of the corner points of this feasible region. The last image, the extreme corner point solution, the area where all constraints are satisfied. The solution is found by evaluating the objective functions at the vertices or corner points of this region. So this image identifies three extreme corner points, and the corresponding solutions is point A, x1 is equal to 0 balls, x2 is equal to 20 mugs, with a resulting profit of z is equal to $1,000. And the point B is x1 is equal to 24 balls and the x2 is equal to 8 mugs, with a resulting profit of z is equal to $1,360. And the point C is x1 is equal to 30 balls and x2 is equal to 0 mugs, with a resulting profit of z is equal to $1,200. By comparing the profit value here, the optimal solution is determined to be at point B, because which yields the maximum of profit $1,360. That's all. Thank you.
So, good day everyone. So, by the way, my name is Adeline A. Luguanza and our assigned topic is all about the linear programming problem. So, the assigned task that given to me is all about the isoprofit and isocost. But before that, na-discuss naman kaganiha sa first reporter ang linear programming problem, but then ako lang siyang i-recap. Today, I'm holding the same PPT nga makita sa screen, makita ra sa screen na ako ara pong gibasa, na same lang sa screen na ako ang i-display. So first is what is isoprofit and isocost method? So isoprofit and isocost method is used in economics and also in a business, particularly in a linear programming and also in a microeconomics. So, ginagamit ang isoprofit and isocost method for the linear programming and the microeconomics or in a business. So, ang challenge that kay kung if ever na daghan kayo og constraint, those constraint are mga financial constraint, mga physical constraint, lisod kayo panghitaon asa ang best optimal solution. So mao to na ay isoprofit and isoprofit or isocost method for us to easy to identify asa makita ang feasible region and also the optimal solution. Next is what is the LP or LPP, which means the linear programming problem. So ganyan discuss naman sa first reporter sa ang linear programming problem, but then I would like to recap lang po that linear programming problem is all about the mathematical techniques used to optimize and maximize or minimize the object, the function that is all set of constraints. So mo to ang meaning sa linear programming. So ang linear programming kung naay mga kuan na mga tawag aning mga constraints, so dili na to siya makuan dapat, so i-convert na to siya into a mathematical techniques. So and also a feasible region, unsa ang feasible region kani sila ang set of all possible constraint or that satisfy all the problem constraint. And also, the optimal solution is the best point within the feasible region that is maximum or yield or maximum profit and a minimum cost. So, mao to ang pasabot sa feasible region and the optimal solution. So, ang isoprofit, again, ang isoprofit and isocost, gibuhat siya for us to, ginagamit siya para dali lang makita ang feasible region and also the optimal solution sa kuan. Kay example, daghan kaayo, so lisod pangitaon. So, ginagamit siya for us to easy to identify where the feasible region and the optimal solution. Okay, so since we already done discussing what is isoprofile and isoprofile in help in linear programming, so karon ato ana po ko anon is example. So like for example, na ay problem. So mo ang problem. Like for example, to maximize z 120x and 100y. So mao na ang kontahay, mao na ang problem. So sa problem na gyud na mga constraints. So like for example, mao na ang constraint na given. So, ang buhaton, step 1, ang buhaton is converting all inequalities into equal. So, like for example, na ay ka na mga greater than o less than, ikambyuhan nimo siya into an equal sign. So, after that, na ma-change na siya, step 2. So, sa step 2 is, kumbaga, simplification. So, to simplify, so to isulat na nimo tong mga na-convert na nimo. And then, the same time, pangitaon nimo sa ang ilahang common na maka-divide sa ilaha. So like for example, this one. So C1. So C1 or the constraint 1 is 10x plus 5y. So mao na ang equals 80. So mao na ang first constraint. So the common sa ilaha is 5. So ang buhaton 10x plus 5y is equals to 80. So divided by 5, 10x divided by 5, 5y divided by 5, and equal to 80 divided by 5. So, x ay 10 divided by 5 equals to 2x. And then, 5 kay, ma-crush naman na siya. So, y na ang mabilin equals to 80 divided by 5 equals to 16. So, mauna ang buhaton. So, gikan sa step constraint 1 to constraint 4, the same lang gihapon ang imuhang buhaton to hanapon lang nimo kung unsa ang ilahang common, and then makita na nimo ang result. So sa result, mauna na siya ang gitawag na plotting lines. So step 3. Sa step 3, tanan constraint imuha na pug sulaton. Then example, sa example 1 constraint. So like for example, 2x plus y is equal to 16. Mao na ganiha ang result sa step 2. And then ang buhaton is that ang y-intercept set x into a 0. So para makuha nimo ang x, buhaton nimo into i-convert nimo sa pulihan nimo og 0. So like for example sa 3a, sa makita ninyo 2 ang x gipulihan og 0 plus y is equals to 16. So ang nabili na lang kay pilaman. So ang nabili na lang is 0 and 16. So para pod sa pikas na pod at the same time para makita na po nato ang y, pulihan na po nato para makita nato ang y, pulihan na po nato ang y og 0. So karon same process ng gihapon na pag y-intercept set x into a 0. Pag set x-intercept set y into a 0. So mao na ang calculation, the same process. Sa pikas pod mao na ang mga intercept point. So, mo nang gamiton sa pagplot. So, like for example, hantod na siya sa 4. So, constraint 4. The same process lang gyapon or the same method or the same pabalik-balik lang ana lang gyapon, intercept x into 0, intercept x y into 0, ana lang gyapon ang buhaton hantod sa constraint 4. So, mao na siya ang buhaton na step by step hantod sa mag-graph na ka. So, sa pag-graph na pod, dito na nimo katong mga nigawa sa step 3, mao to ay mong gamiton sa graph. So, since we are already done sa problem, so sama na sa step 3. So, karon sa pag-plot na pod og sa katong mga results sa step 3, ato ana siyang i-plot para makita nato kung unsa form sa ato ang nakita. So, karon is that makita nato ang graph. So, mo ni siya ang graph. So sa graph makita ninyo na naadra ang feasible region. So kanang draa mao na siya ang feasible region o kanang na satisfy niya ang tanan constraint. So makita ninyo dira na ay P1, P2 and P3. Then sa baba P4, P1, ay Q1, Q2, Q3 ka na i-explain ako na niya. So karon sa makita ninyo mo na ang feasible region. Dira sa graph makita ninyo na ay M, na ay point na ay point dira ang M. So nag-intersect ang duha ka constraint. So the value of constraint na nag-intersect is that x5 and yx represent coordinate optimal M where the object function maximize within the feasible region. Dira sila na-maximize sa feasible region, dira sila nag-intersect. So karon unsa naman na sila na mga constraints. So that constraint is the constraint 1 which simplify the form katong constraint 1 kaganihan na 10x plus 5y, then kato na convert naman to siya, so 2x plus y equals to 16. Then the constraint 2 mao sila ang nag-intersect, which is the 6x and plus 6y, or the x plus y is equals to 11. So dira nag-intersect. So the optimal point M na katong nakita nato ganiya sa graph is the intersection line that respond the two active constraints. So mao to sila ang two active constraints. So to calculate M, the optimal point, to find the coordinate x and y, solve the system linear equation. So isolve na to tong duha mag-intersect. So 2x plus y is equals to 1, then 2x plus y is equal to 11. So step 1 is to subtract equation number 2. The equation 1 is 2x plus, kumoto siya ang mo ng step 1. So isubtract nimo ang equation 2 from equation 1. So manang result na x ay 5x. Then number 2, substitute x5 into equation 2. So the result is y6. So makita naman isa naman dira sa example kung unsaon pagkuha. Therefore, the coordinates of optimal M are 5 and 6 where the maximum value is z is achieved. Dira na achieve nato ang katong tawag na ating maximize na nato ang gipangita. So karon the higher label or the P2 and Q1 mauto siya ang nag-respond na maximum possible profit of Z and 1,200. So optimal maximum value Z is still satisfy all the constraint. So karon, di ba nakita naman nato kung unsa tong mga value. So the optimal value of Z is calculated by substituting the X into 5 and y into 6. Kato nakuha nato ganiha. The object function from atong problem na z is equals to 120x and 100 plus 100y. So pulihan lang nato ang x into ang x sa value nga 5 and ang y sa 6. So karon makita na nato dira na gi-change na. So na-change na ang 120 times 5 to 100 times 6 equals to 600, 600, 600 plus 600 equals to 120. So mao to. Ang sa kuan naman sa kanang lower line nakita nato ganiha. So na P1 and Q1 is respond the arbitrary chosen lower profit Z is equals to 600. Kung 600 is constant na siya. So ang formula ato, or to get what's the formula kung asa ang lower line label kung response arbitrary na choose na 600, start that ikuan nato atong mga function katong Z is equals to 120 plus 100y ana. Then choose ang constant naman daan ng 600, and then i-find gihapon kung sa common sa ilaha, then 20 ang common sa ilaha, then i-divide sa 20. So at simplified that the satisfied masulat na nato siya. So kung mahuman na nato, makita na nato ang common sa ilaha, then the simplification ana is that 6x plus 5y is equals to 30. So mao to ang pagkuha sa ato ang problem na gi-solve. And also lastly, kay ang ato ang goal gyud diri sa maximum, or ang ato ang goal sa maximum is to find the largest possible value of object function can achieve. Kung sa minimum, to find the smallest possible value object function can achieve. And also, sa maximum na side, maximum is often associated desirable outcome like profit, revenue, production, and output. Kung sa minimum, associated with the undesirable outcomes like cost, waste, or time. And also, sa linear programming, ang maximum is the optimal solution, is the feasible region. Boundary is the farthest in the direction of increasing z. Kung sa minimum, optimal solution is the point of feasible boundary that is closest, directly decreasing the z. So, sa minimum, maximum na side sa isoprofit, that line move outward or away from the origin until it touched the last point from the feasible region. Pag sa minimum naman, the S cost line move inwards or towards the origin until touch the first point of the feasible region. So that's the end of my report and how importance of isoprofit and isoprofile in linear programming problem. Again, the importance is that we use isoprofit and cost method for us to easy to identify which is the optimal solution or the feasible optimal solution or the feasible region. Okay, like for example, kung daghan na kay constraint, lisod kay pangitaon ang feasible region and also the optimal solution. So the best way to use para mapadali makita ang optimal solution pag daghan na kayo ang mga feasible region or mga constraint rather, daghan na kayo, we use isoprofit and isocost method to easy for us to identify.
So good day everyone, I'm the next reporter and my topic is duality theory of linear programming. So introduction of duality theory. So theory of duality is important idea siya in operations research. Also study po siya kung unsaon pagbuhat og base or possible decision, then na-develop po siya first in linear programming and ginagamit siya sa other field such as non-linear programming, networks, and game theory. So, duality theory. So, every linear programming problem ginatawag siyang the primal, while ang other related problem is ginatawag siyang the dual. So, ang relationship nila between the primal and the dual, gipakita ang essence of duality nga both nag-represent sa same situation pero different viewpoint. Like for example, if ang primal is about maximizing profit, then ang the dual is about minimizing cost. So for example, a small company in Melbourne nag-produce of office furniture. So producing these items need of 8 kilograms of wood and 5 kilograms of metal and is sold of $80. Addict uses of 6 kilograms of wood and 4 kilograms of metal and it's sold for $60. And Asia requires 4 kilograms of both metal and wood and it's sold for $50. So, ang company wants to maximize profit pero naalang salay 100 kg of wood and 60 kg of metal kay limited lang ila ang resources. So, for problem P1 is max z equal 80x1 plus 60x2 plus 50x3. So, ang company wants to maximize profit. So, ang kaning x1 and x2 and x3 is mauni siya ang number of products na i-produce sa company. So, each product gives a profit of 80 per unit of product 1, 60 per unit of product 2, and 50 per unit of product 3. So, ang company wants to make as much money as possible gikan sa tulo ka product. So sa wood constraint is na 8x1 plus 6x2 plus 4x3 less than 100. So total use ni siya sa one resource, like for example sa wood. Then sa metal constraint is na 5x1 plus 4x2 plus 4x3 less than 60. So, mao ni siya ang total use of other resources. So,
For next is sa x1, x2, and x3 greater than 0. So, this means nga dili makaproduce a negative number of items production must be 0 or more. So, overall, ang company wants to know kung pila each product ang maproduce para makakita sila most profit without using the available 100 kg of wood and 60 kg of metal.
So for other slide is na ay big company sa Melbourne nga naga-produce sad og furniture for many years. Then na ay other company nga naga-produce sad og same item. So ang big company na-filtrating siya iyang gibuhat is kanang gipalit niya ang mga resources sa small company. So in that way wala siya maging ka-kompetensya kay dili sa siya ganahan og naay ka-rival. So, like for example, sa other products, imagine na ay big burger chain like Burger King. So, ang Burger King is nakabalita siya nga na ay new local burger shop nga halinon tas famous. So ang gibuhat sa Burger King is kanang para wala siya kakompetensya is nag-offer siya nga paliton ang kaning new burger shop para iwas rival sa maong business. So, ang large company wants to buy the small company's resources in a small amount pero nag-offer gihapon sila for enough price para mag-agree gihapon ang kaning small company o kanang di-use linear programming para mabalahan ang best offer nga makasave og kwarta.
So that's all po. Thank you.
The challenge for this large company then is to develop a linear program which will determine the appropriate amount of money that should be offered for a unit of each type of resource, such that offer will be acceptable to the smaller company while minimizing the expenditures of the larger company. So these are the problem day 1 formula. The minimum W equals 100y sub 1 plus 60y sub 2. And we're going to answer this given problem. But first, let me explain what are the different elements or equation na makita nato dira sa problem or dira sa formula. First is W. W represent the total cost that the company wants to minimize. Next is y1 or y sub 1 and y sub 2. These are the division variable. So they represent the amount of money offered of each unit of the two types of resources. Next is 100y1 or 100y sub 1. This means that each unit of resources type 1 cost of 100, then the total cost of resources of type 1 is 100 times the number of the unit of 1. The next is 60y sub 2 or the 60y2. This means that each unit of resource also of the type 2 that costs 60, then the total cost of resources of type 2 is 60 times the number of the unit of y sub 2. In step 1, simplifying the constraint. So, naati tulo ka problem diri ang kinahang nato isolve. So, number 1 is 8y plus 5y equals 80 and 6y1 plus 6 plus 4y2 equals 60 and 4y plus 4y2 is equals to 50. The next is step 2. Solve the pairs of the equation. So, 8y plus 5y equals 80 and 6y plus 4y is equals to 60. So, ang pair sa equation is number 1 and number 2. The next na pod is multiply the secant by the 1.25 which is ang 6y plus 4y equals to 60. Ang 6 mamahimo siya nga 7.5. How to get the 7.5? You multiply the equation 6y plus 4y equals 60 by 1.25. So 6y plus 1.25 ay 61 times 1.25 is equals to 7.5. Next, the resource is 2, which is the 4. So 4 times 1.25 is equals to 5. And same gihapon sa 60. So 60 times 1.5 is equals to 75. So nakuha na nato ang equation 2. So ang new equation mahimo siya nga 7.5y1 plus 5y2 is equals to 75. Instead of katong dati nga 6 plus 4 equals to 60. So next is i-subtract na pud nato. So every resources, so resources 1 minus resources 1 and resources 2 minus resources 2. So which is, ang resources 1 example is 8 minus 7.5 plus 5 minus 5 equals 80 minus 75. Then ang next nato is i-subtract. So 8 minus 7.5 equals to 0.5. The next is 5 minus 5 is equals to 0. And 80 minus 75 is equals to 5. Then after ana is i-add na pud nato. So 0.5 plus 0 is equals to steady 5. 0.5. Then equals to 5. Then after ana is hanap po nato ang value sa y1. So 0.5 is equals to 5. So next is y1. So 5 divided by 5, 0.5 is equals to 10. So ang value sa y1 is 10. Next is i-substitute na po. So kay ang y is ang value niya is 10. So i-substitute nato ang 6 into 10. So 6 times 10 plus 4y2 is equals to 60. Ganun 60 man. Kay 6 times 10 is equals to 60. So naan ay value. So 60 plus 4y2 is equals to 16. Ang next na pud ana is pangitao nato ang value sa y2. So 4y2 is equals to 60 minus 60 is equals to 0. That's why ibutang diri sa baba 4y2 is equals to 0. Next is divide na pod. 0 divided by 4 is equals to 0. So ang value sa y2 is 0. So the solution is y1 is equals to 10 and y2 is equals to 0. Therefore, ang point A is 10 and 0. So diri na po sa B from 2 and 3. So ang y1 is 6y1 plus 4y2 is equals to 60 and 4y1 plus 4y2 is equals to 50. Actually, same formula lang, same paggamit lang sa mga equation, but different lang ang ilahang value. So, ang y1 sa B is 5, then ang y2 is 7.5. Same lang gihapon C from 1 and 3. So 8y1 plus 5y2 equals to 80 and 4y1 plus 4y2 is equals to 50. So ang point C, ang y1 niya is 5.83 and the y2 niya is 6.67. So diriya sa next slide, which is the step 4, diri na ako gibotang tanan kung makita nato diri ang tama kung asa atong gipangita nga minimum possible value of the W. So there is a step 4, compute the objective's value of W or the total cost equals 100y1 plus 60y2. So ang point na ay point ABC, y1 10, 5, then 5.83, then ang y2 is 0, 7.5, and 6.67. So, giun sa pagkuha sa value or giun sa pagkuha sa or sa paghanap sa minimum possible value of W. So, 100. So, asa gikuha ang 10? Ang 10 is naa diri sa y1. So, ang value sa y1 sa point A is 10. So, times na sila. Then, plus 60, 0, since ang value sa y2 sa point A is 0. So, 100 times 10 plus 60 times 0 is equals to 1,000. Same gihapon sa B. 100 times 5 plus 60 times 7.5. So, 150. Then, sa C na put is 100 times 5.83 plus 60 times 6.67 is equals to 182. So, diri makita na to jud kung asa ang tama nga answer, ang tama nga gipangita or ang total cost. So, ang tama nga answer is 950, which is ang point B. So, ang step 5 is find the minimum. Since even sa step 4 pa lang is nakita na nato ang minimum. So, the smallest value of total cost is 950, which happen at y1 equals to 5, then ang y2 is equals to 7.5. Then ang total cost is equals to 950. So ang final answer is 950. Next, let's proceed to the primal and dual number. So when we see primal number, the primal number is the original linear programming problem that want to solve. Usually, it is routine maximization with less than constraint and non-negative variables. So, primal number, so it is maximize z equals c and tx subject to ax less than b, x greater than 0. So when we see x, it is a decision variable, and a is a coefficient of constraint, and b is a resources limit, and c is a profit or cost coefficient. Next is a dual problem. So when we see dual problem, it is another linear programming problem derived from the primal representing the value of resources of constraint. So it gives a minimum value that equals to the primal maximum. So dual problem standard dual form is a maximize w is equals to y, t, and b. So, ang y, it is a dual variables, and b is the same right-hand side from primal, and a is the same coefficient matrix, and the c is the pairs of the right-hand side in dual. And these are the main differences summary of dual and primal problem. So, the objectives, the meaning, the variables, constraints, relationship, objectives, value, and quality principle. So, ang objective sa primal is usually maximize, the dual is usually minimize, and the meaning is find the best use of resources, while the dual is find the value of resources. And the variable from primal, decision variable of x and j, and the dual is shadow prices of y. And the constraint, it is based on the variable resources, and the dual is based on profitability condition. And the relationship is original problem from primal, and the dual is derived from the primal or the mirror image. The next is the objectives value. So z, which stands for maximum, and w stands for minimum. So the quality principle, z is a less than w or the weak duality, and z is equals to w or the strong duality and optimum. Last was general rules for constructing dual. So number 1 is the number of variable in the dual problem is equal to the number of the constraint in the original or the primal. problem. And the number of the constraint in the dual problem is equals to the number of variables in the original problem. And the number 2, the coefficient of the objectives function in the dual problem come from the right-hand side of the original problem. The number 3, if the original problem is maximum model, so the dual is the minimum model. If the original problem is minimum model and the dual problem is a maximum problem. Number 4, the coefficient of the first constraint function for the dual problem are the coefficient of the first variable in the constraint for the original problem, and similarly for other constraint. And last, the right-hand side of the dual constraint come from the objectives function coefficient in the original problem.
Good day everyone. So let's proceed now in the relationship between the primal and dual. But before that, I would like to introduce myself. By the way, I am Jessica Emalintad and I am the one that assigned to report this. So first, what is relationship? So again, since na-discuss naman ganiha unsa ang primal and dual, now I will discuss the relationship of these two problem. In linear programming, the dual of the dual problem is again the primal problem. Next definition niya is either the problem has an optimal solution if and only the other does. If the problem is feasible but unbounded, then the other is either infeasible or feasible unbounded. So just to easy understand, in linear programming, the primal problem is maujud na ang original naga-optimize sa problem para ma-solve. Then, ang dual is related na sila duha. Ang dual naga-derive siya og mathematical problem that trying to solve from the primal. That also provide sila og different perspective pero same sila og situation and solving. Next is the simplex method. The graphical method is useful only for problems involving two decision variables and relatively few problem constraint. So means ang graphical method daw is useful ng problem pag duha ang decision variable nga ma-involve and also if naa siya few problem constraint. So naa siya question. What happened daw when we need more decision variables and more problem constraint? So, we are going to use the algebraic method called the simplex method, which is developed by George B. Danzig in 1914-2005. So who is George B. Danzig? Si George B. Danzig karin siya as American mathematician. Siya ang known as a father of linear programming. Kani si George B. Danzig kay gipanganak siya sa Portland, Oregon. Nahuman po siya og eskwela sa University of Maryland in 1936. Nakahuman po siya og master degree sa mathematician in University of Michigan. And also nahuman pa jud niya ang doctorate niya sa University of California, Berkeley in 1946. Actually, daghan kay siya na develop si George B. Danzig. Isa na ang simplex algorithm sa linear programming na pasabot na is core tool for solving linear programming problems. Next is standard minimization. Problem in standard form. A linear programming problem is said to be standard minimization problem. A standard form of mathematical model is the following form na siya. Minimize the objective function. Minimize equals 1 x1. Makita ninyo sa PPT. To explain this, the essence we are going mag-try na to i-minimize ang cost function, whether the c values are cost and x values are variables under the condition that the sum of variables multiplied by the constant, which is the a is less than or equal to a non-negative number and all x values are non-negative. So now let's proceed to the basic and non-basic variables. Basic variables are selected arbitrarily with the restriction that there be as many basic variables as there are equations. The remaining variables are non-basic variables. Example na asa koan, x1 plus 2x2 plus s1 equals 32. 3x1 plus 4x2 plus s2 equals 84. This system has two equations. As you can see, the four variables as basic variables. The remaining two variables are the non-basic variables. A solution found by the setting the two non-basic variables equal to 0, and ang solving for the two basic variables, it is basic feasible solution. In simple terms or simple explanation, basic variables are the main variables na mo solve sa equation, and also the number of variables must match a number of equation that you had. And for non-basic variables, mao ni ang mga variables na set to 0 to help you solve for the basic variables. Example, makita ninyo diha sa screen, kanang duha example na siya sa basic variable. You know why? Kay naaman sila number, o just like what they say, pag non-basic variable daw, kay dapat ang variable set niya ka mag-equals to 0. Next is the optimal solution. Optimal solution is the best values of the variables that either minimize or maximize the objective function. The next definition of it is, the optimal solution daw is to find the simplex method that involves deciding which variables should become positive and which variables should become 0. Ang goal lang jud sa optimal solution in a simple term kay naga-lower siya og total cost of, or naga-increase siya sa usa ka profit, or by strategically changing the values of the variables. So,
good afternoon, ma'am. I am Ira Larez Licopo and I am the last reporter. So, my topic is all about minimizing the problem. So, mali siya ang last topic sa linear programming. So, ang atong patungtaran is minimize the cost. So, ang naadiri sa slide is c that x equals 3x1 plus x2 plus 9x3 plus x4, and x1 plus 2x3 plus x4 equals 4, and x2 plus x3 minus x4 equals 2. So, ato siyang gamiton diri sa iteration 1. So, step 1, write the equations in terms of basic variables and z in terms of non-basic variables. So, x1 equals 4 minus 2x3 minus x4, x2 equals 2 minus x3 plus x4. Close and open parenthesis natin siya. So, c dot x equals 3, close and open parenthesis, 4 minus 2x3 minus x4 plus, close and open parenthesis, 2 minus x3 plus x4 plus 9x3 plus 6, 4. So, ang iyahang c dot x is 14 plus 2x3 minus x4. So, ang x1 and x2 are basic variables, while ang x3 and x4 are non-basic variables. So, ato ang isubstitute ang x1 and x2 into the objective function. Mao to ang c dot x. So, after simplifying, nakuha nato ang c dot x equals 14 plus 2x3 minus x4. So, asa man gikuha ang 14. So, ang 3 ato siyang i-multiply through the parenthesis. So, 3 times 4 is equals to 12, and 3 times 2x3 is equals to 6x3, and 3 times negative x4 is equals to 3x4 plus 2. So, ato ang i-plus ang constant. So, meaning, katong 3 times 4 equals 12. So, wala man siya katong mga x1, x2, x3. So, ato siyang i-plus. So, 12 plus 2 is equals to 14. So, asa man po nato nakuha ang 2x3. So, negative x minus 1 plus 9 is equals to positive 2. So, mauna siya ang 2x3. While diri sa x4 is negative 2x4 plus x4, which is 1 na siya, kay imaginary 1, plus x4 is equals to negative x4. So, mo nato nakuha ang c dot x equals 14 plus 2x3 minus x4. So, let's proceed to step 2. So, as x3 and x4 are non-basic variables, they are initially set sa 0. So, x3 equals x4 is equals to 0. So, para ma-minimize nato ang c dot x, we look at the coefficients of x3 and x4 sa equation. Since increasing x4 decreases the value of cx. So, because sa iyahang negative sign. So, ang x4 should enter the basis. So, ang ato ang entering variable is ang x4. So, ang ato ang leaving variable is ang x1. Kung ano man. So, when ang x4 increases, then x1 will eventually reach 0. Kay based sa iyahang first equation. So that means x1 will leave the basis and x4 will replace it. So kani siya na step is nagfollow siya sa simplex method rule. So the variable that first hits 0 becomes the leaving variable. So let us proceed to iteration 2. So ang step 1 is write equation in terms of basic variables x2 and x4 and z in terms of non-basic variables x1, x3 as they are 0. So that means we express everything using x2 and x4 kay x1 and x3 are not part of the current basis. So naset na sila into 0. So, x4 equals 4 minus 2x3 minus x1. Kani siya, gikan ni siya sa one of the constraints where we solve for x4 in terms of x1 and x3. x2 equals 2 minus x3 plus, close and open parenthesis, 4 minus 2x3 minus x1. So, here, ang x2 is nagdepende siya sa both x3 and x4. But since we already have x4 equals 4 minus 2x3 minus x1, we substitute it into the equation. So 2x2 equals 6 minus 3x3 minus x1. So atong i-combine ang similar terms to get the simplified form. So, diri sa c dot x equals 14 plus 2x3 minus, close and open parenthesis, 4 minus 2x3 minus x1. Pasabot ani, we plug in the value of x4 into the cost equation. So, ato siyang isimplify. C dot x equals 10 plus 4x3 plus x1. So after simplifying, this shows how the cost depends on x1 and x3. So since ang x1 and x3 are 0, kay non-variables are always 0 in the current solution, so they cannot be reduced further. So therefore, c dot x cannot be minimized further. So, z equals 10 is the minimum cost. So, when ang x1 equals 0 and x3 equals 0, we get z equals 10. So, ang value of the constraints kay x1 equals 0 and x2 equals 6 and x3 equals 0, then ang x4 is equals 4. So, ang ato ang final optimal solution is x equals 0, 6, 0, and 4. So, nga naman ang z equals 10, yun sa man siya pag-calculate. So, we already have the cost equation from earlier. Mao to ang C dot x equals 10 plus 4 x3 plus x1. So, ato siyang hinumduman na kini siya nga equation shows how the total cost depends on the variable x1 and x3. So, in this iteration, ang x1 and x3 are non-basic variables, which means x1 kay equals 0 and x3 is equals 0 gihapon. So, now, atong i-substitute ning value into the cost equation. So, C dot x equals 10 plus 4, which is 0 plus 0. So, ang iyang nabili na lang is ang 10. So, C dot x is equals to 10. So, therefore, Z equals 10 is the minimum cost. So, para mas masabtan, mauni siya ang summary sa variable values. So, ang x1 is 0 naman siya, and x2 is 6. Then, x3 is same siya sa x1 na 0 na pod. Then, ang x4 is 4. Then, ang ato amang final optimal solution, di ba, kay 0, 6, 0, and 4. So, ato ang minimum cost, atong i-plus ang 6 and 4. So, equals 10. So, mauna siya nga to ang Z equals 10. And that's all. Thank you.